Welcome, everybody, to the statistics topic session, two sample tests of hypotheses. In this session, we are going to expand from the previous chapter in which we were doing one sample test to two sample tests. Um, in here, we will select random samples from two different populations to compare the two populations and determine whether their means could be equal. And we're also going to investigate whether the distribution of the difference between the means could have a mean of 0. Some examples of comparing two populations are, for example, the difference in the mean value of residential real estate sold by a male agent and a female agent in Dubai. So basically, when you have two different populations like male versus females, and you're comparing them whether they're the same or not, that is one example of comparing two populations. Another one is if you want to compare the difference in the mean number of defects produced on the day and the afternoon shifts at Coca-Cola. So is the morning shift making more or less or equal amounts of defect compared to the afternoon shifts? These are two different populations, people working in the morning versus the afternoon. Another example here, if there's a difference in the mean number of days absent between young workers, for example, workers below the age of 21 years of age, and older workers, for example, more than 60 years of age in the fast food industry. So if we want to compare whether younger people miss the same amount or more or less days than older workers, for example, somebody more than 60 years. So these are two populations that are independent. They don't affect one another. And we want to compare how they are to one another. Another example here, is there an increase in the production rate if music is piped into the production area? So on the production area, you put music on. Are the employees producing more because there has been music turned on? So you check what is the production rate before music and then after music. Has there been an increase? So now, just like we saw for one sample testing, we have two different methods for hypothesis testing. The traditional method covers 6 steps, okay? And if you visit the channel, we have several videos covering each of the steps individually. This one video will show you what is the difference between testing for one sample versus two sample test. So let's start with step 1, which is state the null and the alternate hypothesis. Just like we had before when we were testing for one sample. The state null and alternate hypothesis has 3 different cases. The first case is in both, in here, we're comparing H0 to H1. And when we're comparing two samples, then we're going to compare the two sample means of two populations. And we're going to see, for example, if one mean is bigger than the other, that means for your H0, the first population is going to be less than and equal to a second population. So this is one of the cases. This is a one-tail test on the upper side. So when we were looking at one sample test, we were comparing a mean of a population to a number. Here we're comparing two populations to one another. Another case that you could have when you're doing your step 1 is if your mean of the one population is less than the second mean of the population. In this case, for H0, if this one here is less than, then the H0 will be the opposite, which is more than and equal to. The equal sign always goes on H0. Okay, in this case, this is also a one-tail test. And this is less than will be the lower side. Now, the third case scenario is when we have an H0 and an H1, where the mean of one population is equal and not equal to one another. That's the last test. This case here is a two-tailed test. And since you have a two-tailed test, then the area of the tails will be divided by 2. Now, the second step here is select the level of significance, the alpha. This is given in each exercise. Basically, the alpha, the level of significance, is the area of rejection. Let me erase this here. Okay, so the alpha is the area of rejection. And here we are rejecting H0. The alpha is the area in the tails. Yeah, from the step before. Yes, this is a one-tail test, two-tail test. Whatever areas on the tail is the alpha. So the alpha here is the level of significance, which is always given in the exercises. The third step, identify the test statistic. Are you using Z or are you going to calculate T? Now, this is all the way from when we introduced sample testing. We use Z statistics when the population standard deviation is given. Now, if they have not given you sigma, the population standard deviation, then they have given you S, which is the sample standard deviation. If you have the population standard deviation, then we have to use T for our step 5 and step 4, test statistic T. So if you have sigma, which is the population standard deviation, then we use Z statistics. And if they have given you the sample standard deviation, then we use the T statistic. That's step 3. Step 4. Now, we have 2 choices. Are we using Z or T? Right, so this is determined in step 3. Step 4, formulate the decision rule. Basically, here you're looking at the area of rejection of H0 and the area of no rejection of H0. So now, how do we get these areas of rejection and do not reject? We get this by determining the critical value. Okay, the critical value is the line on the curve that separates the reject from the do not reject zones. Now, if from step 3 we decided that we were using Z, so you need to find the critical value, the Z value that separates these 2 areas. Okay, so now how do we do this? Basically, in MegaStat, and I will show you how to do this now. If you have to use T to find your critical value Z, I'm sorry, not T, Z. If we have to get the Z, in MegaStat, you basically are going to look for, you're going to calculate Z given a P. The P here is the alpha, the area in your tail. Let's assume we're looking at a sample in which we're looking at a mean 1 more than mean 2. So more than is the upper tail. Okay, so let's assume we're doing here, and we assume that the alpha here is equal to 5%, 0.05. So for a more than, which is an upper tail, let's get the Z value that will separate these 2 areas. The alpha here will be the area where you're going to reject H0. And the other side, which is 1 minus alpha, if we decided that alpha is 0.05, then the area on the other side is 1 minus 0.05, 0.95. So what is this one line? What is this critical value? The Z value that separates these two. So let me show you in MegaStat to get a Z value for step 4. MegaStat, probability normal distribution. Okay, and you have two choices here. Calculate P given a Z, calculate a Z given a P. So here, this P is your alpha. In this case, we said alpha is 5%, 0.05, and here is 0.05, nothing, you don't have to change anything here. Mean is 0, standard deviation is 1. Do not change any of this. So you write whatever alpha you have here, and then you figure out, are you doing upper, lower, upper, or two tails? In this case, it's upper. And it's finished. Okay, so you just have to give the area, let me make this smaller. You just have to give the area, the alpha in MegaStat. Okay, this alpha here is 0.05. The line, the area opposite is 1 minus alpha. 1 minus 0.05 is 0.95, as you can see it here. The line that separates this is your critical value. Okay, in this case is the Z of 1.64. This is the same critical value we were finding for chapter 10 when we were looking at one simple test statistic. Okay, so that is when you're doing the Z value. You go, let me show you once again, data, MegaStat, probability, normal. You just write the Z here and check whether you're doing the lower, upper, or two tails. That is it. Calculate Z given P, put your alpha in here, and then what area are you shading? That is it. All right. So now, that is if you were doing a Z, right? A Z, you get a critical value. We mentioned for our sample here that it was 0.05, and that gave us a critical value of 1.64. Okay, and the area here is 0.95. This 1.64 separates the area of reject H0 from the do not reject H0. So formulate a decision is what is your critical value? What is the critical value that separates the areas of rejection versus no rejection? So now, what happens if you have to do a T? What happens if on step 3, you determine that you needed to use the T distribution? So the logic is the same. Let's assume now that you're having, for example, a two-tail test, okay? Which means two-tail test would mean that you're doing equal and not equal to. Two-tail test, equal and not equal. Okay, so let's assume we're having a two-tail test. We assume, let's give an alpha a value of 10%, 0.10, and it's two tails. So we have here, the area here is alpha divided by 2 because we have two tails. Okay, all right. So the area in the middle is 1 minus alpha, which means 0.90. Again, we're trying to find the critical value in which we have the reject from the do not reject section. So this is the reject H0. Our tails are always the reject 0 zones. The area in the middle is a do not reject H0. Now, when we're trying to calculate a critical value T, we're going to need two things. One, we're going to need the area in tails, which is the alpha, and we're going to need the degrees of freedom. Degrees of freedom, when you have two samples, comparison of two samples here is N1 plus N2 minus 2. Okay, N1 plus N2 minus 2. So let's give some numbers here. Let's assume The sample for the first population, let's assume it's 10. A second sample from the second population was 8. So 10 plus 8 is 18, minus 2, 16. So let's assume we're doing the degrees of freedom equals to 16, 2 tails, and an alpha of 10%. So now, how do we do this in MegaStat? Okay, MegaStat for T, probability, T distribution. So how do we get there? Let me show you the way from the beginning. MegaStat, probability, T distribution. If you are doing T, then you have to go for T distribution. Again, you have to go, there are only two choices, calculate a P, which is the area, given a T, or calculate a T given a P. So just like in Z, the P here is your alpha. We have given it an alpha of 10%. So 0.1 is 10%. Degrees of freedom, we gave it, it was 10 plus 8, that's 18, minus 2, 16. And then you need to tell it, it's either lower tail, upper tail, or 2 tails. So for the sake of explanation right now, we're doing a 2-tail test. And that is it. You tell MegaStat that you want to get the T value, given a P. The P value here is your alpha, which in this particular scenario, we said the alpha was 10%. We give the degrees of freedom, which is N1 plus N2 minus 2. And then you tell which area you are going to refer to. Are you in the upper tail, lower tail, or are you having a 2-tail? And that is it. Okay, let me walk you again. MegaStat, probability, T distribution. You need your alpha. You need the degrees of freedom, N1 plus N2 minus 2. And you need to tell it which area you are shading. In this case, I said the 2 tails. All right, let's see the information that we get. So we get here the the critical value. We have 2 because it was a 2-tail test. The critical value, the T that separate my, do not reject a 0 from the rejected 0. Right? Are the T's plus or minus 1.746. So we have a positive because we have an upper tail, 1.746, and a negative 1.746. Okay? The degrees of freedom is here. This is what we typed. So for T statistics, you need 2 items. You need to figure out your alpha, and that's going to be the p-value written in MegaStat, and you need to calculate your degrees of freedom. Degrees of freedom is N1 plus N2 minus 2. Okay, so that's the 4th step. When you're having T, your 4th step is to figure out the T values that separate your reject H0 from the do not reject H0. Okay, and that is your critical value. All right, 5th step. Take a sample and arrive at a conclusion. This one here is also known as test statistics. This take a sample and arrive at a decision is also known as test statistics. Okay, so basically we do the math in this one. And again, from step 3, you needed to decide whether you were doing a Z or you were doing a T. Accordingly, you did step 4, which is figuring out your line that separates the area of rejection to the do not reject. And if you are doing Z, for example, then you need to do step 5 for Z. And if you're doing T, then you need to do step 5 for T. Now, how do we do this? This is also a MegaStat move. Now, MegaStat is actually in step 4 and step 5. The rest of the steps are not in MegaStat. Let me show you how this step 5 is done. So, data, MegaStat. And then you have a section here, hypothesis test. Okay, how did we do this? Data, MegaStat, hypothesis test. Now, when you had one sample hypothesis testing, then you go hypothesis test, and the first one is for only one population. Now, in this particular section, in this chapter, we're seeing two populations. You do hypothesis testing, and you do the second one down. Compare two independent populations. All right. So in this one window, there are two choices. Either you do data input or you do summary input. The summary input format is very similar to chapter 10. But let's see, what is data input? So data input is you choose data input if, for example, they give you the total number of data points. For example, here, column F and G have the data points for salary of nursery teachers compared to nurses, okay? And let's assume we're going to check whether, let me put here, let me put a hypothetical step one. Let's assume we are going to compare whether the mean, we're going to call nursery teachers group 1 and nurses 2. We're going to compare whether the nursery teachers are paid less money than the nurses. Okay, and if this is less than, then H0 is more than and equal to. All right, so this right here tells me that it's a one-tailed test on the lower side. Okay, so let's go and check it out. Data, MegaStat, hypothesis testing, and we're comparing two independent groups. In this case, the nursery teachers versus nurses. All right, so data input, summary input. When you have the data, raw data like this, okay, like two columns, you need to do data input. Now, how do we enter the data in here? So you go into group 1, and that is your population 1. Normally, you need to be guided of which populations 1 and 2 from the question itself. So let's see. You have decided which one is group 1. You highlight the numbers only. Okay, numbers only. MegaStat will figure out your sample mean, your sample standard deviation on its own. Then you need to decide whether you're doing a t-test or a z-test. In this case, let's assume we're doing a t-test because we only have the raw material. We don't have, for example, the population standard deviation, so it's a t-test. Another thing you have to decide is your alternative. Alternative is your H1. So what are you testing in H1? So let me move this window here. From our hypothetical question here, H1, we're testing less than. Okay, so we go in there and we say less than. Last item to check is your confidence level interval. Confidence interval is 1 minus alpha. So we have not given any alpha here in this particular exercise, but let's do it now, just to have a little bit something more meaningful here. So let's say the alpha here is 0.5, 0.05. 0.05 is 5%. 0.5 is 50%. So no, 5%. So that's our alpha, 0.05. Okay, so data, MegaStat, hypothesis testing, we are doing compare two independent groups. So we say data input, we have the first column. You only highlight the numbers, do not highlight the title. Second column, and we're doing a t-test. You do not want to change anything here, leave it alone. And then the display 90% confidence interval. This confidence interval is the 1 minus alpha. If this was if the alpha is 0.05, then you want it to be displayed at 95%. So 1 minus alpha. And that is it. Okay, so in this case, we get to see the t-value and the p-value. Okay, so this right here, the point, this one right here, this is your step 5, which is also your test statistics. Sta, oops. Test statistics. Okay. Now, this is if we were, and you get to see here, we put the numbers straight. What are the numbers? We added like these columns here. Okay. Now let's see the output. The output, MegaStat calculated the mean for each of the samples, the standard deviation for each of the samples, and it gets here the number of data points. It gives me here the degrees of freedom. The degrees of freedom is n1 plus n2 minus 2. In this case, 12 plus 8 minus 2 equals 18. Okay, so here's a way that you can, in which you can confirm that you've done the right thing here, getting your degrees of freedom accordingly. And this here, we were looking at test statistics for the t-test. Okay, now what happens, let me show you here, what happens that if instead of having the raw data itself, they give us information in which we can do a summary. Okay, group 1 and group 2 summary. So let me show you how would you put that in MegaStat. Data, MegaStat, hypothesis testing, and you do mean versus hypothesized. So you see here it's only for one population. You have two. So you're going to compare two independent groups. And we saw already when to use the summary input. If you have, data input, like when they give you the columns straight. Now, if they give you the summary input, then you use summary input, and it tells you right here the structure that you need in MegaStat. For each group, select ranges with the label, mean, standard deviation, and sample size. So, which these templates here, we already worked out when we were looking at chapter 10. So we're just adding, for chapter 11, we're adding one more column. Like chapter 10, if you have the template for chapter 10, it's only this section here. Chapter 11 has another column because we're comparing two different populations. So let me see. Oh, MegaStat just stopped. 1 second. Okay, so if the exercise has given you a summary, meaning they've given you sample mean, standard deviation, sample size, then you go data, MegaStat, hypothesis test, compare to independent groups, and you will be looking at the summary. Okay, this labeling, MegaStat always needs a label, the mean, standard deviation, and sample size. Always this four and in this order. So for group 1 or population 1, whoever population 1 is for you, you highlight 4 cells from your label, mean, standard deviation, and sample size. You go to group 2 and you highlight the second group, 4 cells in that order, the name, simple mean, standard deviation, and sample size. This 0 here, leave it, do not touch it. If they have given you, if you decided that you were doing the z-test, then you click on the z-test. If you decided you were doing the t-test, then you click the t-test. We're only looking at these two options. Now, alternative. What are you doing in H1? What were you doing in H1? Were you doing greater than, equal, not equal, or less than? It is definitely here according to step 1. And the confidence interval is the 1 minus alpha. Okay, all right. So you press OK, and this is your output. And it will give you here, for example, we have here that we were looking at the Z table because we assume we were given the standard deviation is of the population, sigma. Okay, all right. So data MegaStat hypothesis testing compared to independent groups. Couple of decisions you have to make. First, do you have the data input, which means do you have columns, or do you have the summary input? Okay, and the summary input is like this, where you have the label, the simple mean, standard deviation, and the simple. Data input if you have columns. Let me try to show you the columns. For example, these two columns here, nursery teachers' salaries and nurses' salaries. So this, if you have columns with information straight, then hypothesis test compared to simple means, and you do data input. If you have a summary, then you do the summary right here. Figure out what you're doing in each one. 1 minus alpha, is it a Z test or a T test? And it's finished. Kalas. Okay. The last step is, what are you doing? Are you going to reject or not reject H0? Accordingly, you just need to write one sentence, whether you are on the do not reject zone, right? And what does that mean? Or if you're in the one of the reject zones, if you're in one of the tails, if you are rejecting, what does that mean? So this here is just putting in one line in a sentence, what are the results of the test. Now, that was the traditional method. The second method for hypothesis testing is the p-value method. And just like it was when we were comparing one simple mean, if this is the same rules, if your p-value happens to be less than your alpha, then you have to reject H0. If your p-value is more than your alpha, then you do not reject H0. P-value bigger than your alpha, you do not reject. P-value less than your alpha, you reject H0. And that is it. Hope this helps. Comparing two populations to one another, and how to do the calculations in MegaStat. Thank you so much. Enjoy. Bye-bye.